We're going to take another look at example 3A. It's the Try It. It is page 18 in the companion book if you have it. And I'm going to do a lot of this work on a separate sheet of paper. So here's what we're going to do. Let me scoot this up. I'm going to start out, first of all, I'm just going to start out with f of x equals, let's draw braces. And this is where I'm going to write my rules. I'm going to put a space. We're just going to start filling things in. And my domain, so I know each time I'm going to have x values that are going to be between two numbers. And there will always be a less than of some sort, either less than or less than equal to, depending on what kind of endpoints are used. So when I'm looking for my domain, I'm looking, okay, x is going to be between which two x values? All of my x's have to be between these 2 points on each of the little pieces of my graph. So let's come back up here. So let's look at this first section right here. So if you look at it, look at the x values of your endpoints. And again, we're talking domain. We're looking at x values. So what we're saying, even if you put the rulers here, so any acceptable x values, which would be my domain, are within the interval between my rulers, left, right. Okay, not dealing with y's at all. It is between these two rulers, left, right. So if you look, what is the x value of this endpoint? Well, if you come down, I'm scaled by 2's, so that is going to be a -5, and over here I'm at -1. So x has to be between -5 and -1. So let's fill it in, -5 and -1. Now, I have both of these are closed dot, which means those values are included. So I'm going to put the little equal sign. So my domain of my first function is x such that x has to be between -5 and -1. Now I need the equation of the graph. This is a constant. These are super simple. When you don't have any rise or run, you just have a I shouldn't say run, there's no rise. If you have just a horizontal line, your equation is y equals whatever the y value is on this line. Well, the y value, let's see, here's 4, 6, 8. This is halfway between 6 and 8. Well, halfway between 6 and 8 is 7. So that's our first line. That is the first piece of our piecewise defined graph. Now let's look at the second portion. And again, look at your domain. You're starting x value, you're stopping x value. So my x's start at -1, and then they end at, that's a +3. So x has to be between that's a -2. I forgot we're scaled by 2. -2 and +3. Now, because over here, I use this endpoint as a closed dot, and this one also shares that same endpoint, one of them cannot be considered a closed dot. One would have to be an open dot. It wouldn't matter. I could have left this as a less than and made this one less than equal to. So in other words, open dot, closed dot, that's fine, but you can never have closed dot, closed dot. So we're going to leave this as open dot, and now here closed dot. So I'll put a little equal sign under there. So x is between -2 and 3, up to -2 and 3. So it is between -2 and 3, but it does not include -2. It would include -1.9999999 off to infinity. That's fine, but it would never quite be -2, open dot. Now my equation. Let's see, can I pull, let me look at this. Let's do this the short way. So I'm going to look at my second line. We'll call it line 2. So we'll look at the line 2. Okay, my slope. Let's take a look. So I'm going to go from, this is negative, what is this, 7? This is 7 to 2. Well, 7 minus 2 is 5. So in other words, I went, and that's down 5. So that would be negative 5. I went down 5 units. That's my rise, down 5. And now how many do I have to go over? 2, 4, 5. So that is a right 5. Well, if we simplify this, we have negative 5 over 5 is negative 1. So that's my slope. Slope is negative 1. Do I have a y-intercept? I do. Let's see, y-intercept. And my graph is crossing at y equals 5. There's 4, there's 6. Halfway between is a positive 5. So that means writing this, y equals mx plus b. Well, y equals, my m value is negative 1. I don't need the 1 there. Negative is very important though. And my y-intercept, my b value is 5. So that is the equation of the second line. And now let's just drop it in. Negative x plus 5. And now let's look at the third segment, third little piece of the graph. So again, let's look at the x values. So here we start at x equals 4 and we end at x equals 6. So my x values are between 4 and 6. And right here at 4, it is an open dot, so it's just a less than. But then at 6, it is a closed dot, so it is a less than equal to. And now let's determine the equation of this graph. So let's go line 3. What do we got here? Slope. You know what? Let's do slope algebraically at this one. Let me pull 2 points. So we are at, where are we at? We are at 4, 5. So I'm going to jot this down. 4, 5. And here we are at 5, nope, 6. Are we scaled? We're scaled by 2s on this one. 6, 9. Okay, so now let's do slope algebraically in case you don't want to do the rise over 1 where you're counting. So we remember that is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So my second y is 9 minus my first y is 5 all over my second x is 6 minus my first y is 4. 9 minus 5 is 4. 6 minus 4 is 2. We simplify that. We have a slope of 2. I don't have a y-intercept that I can just really easily see. So what I'm going to do is I'm just going to pick any point on this graph. Let's go with the end point. Let's go use 4, 5 again. 4, 5, and I know my slope. So if I go point 4, 5, and I know my slope is 2, let's find b. So again, go back to slope-intercept form, y equals mx plus b. And now let's substitute 4, 5 for our x and our y here. So my y is 5 equals my slope, which is 2, my x, which is 4, plus b. B is the unknown. If I'm down to one variable, I could solve for that. Simplify. 5 equals 2 times 4 is 8 plus b. We'll subtract 8 from both sides. 5 minus 8 is a negative 3 equals b. And again, remember, this is your y-intercept. So if we write this as an equation, again, y equals mx plus b, we have y equals, my m is 2, y equals mx plus b, my b is a negative 3. So this is the equation of my third line, 2x minus 3. And again, you can even look at this graph and kind of verify that negative 3 for the y-intercept. If you just take a ruler and line it up, ta-da, we are going through negative 3. So there it is. And again, on a multiple choice exam, the best way to go about looking at it, look at your endpoints. Maybe look, where do you have a constant? That's always easy to pick out. And are these the endpoints of the constant? Here we have negative slope. Look at the endpoints. Do you see a rule in your piecewise defined function that would have a negative? Does it match the endpoints? So a lot of times when you're doing a multiple choice test with a piecewise defined function and you've got to match the correct graph to the algebraic representation or vice versa, best way to do it is to check your endpoints. Also look, open dot, close dot. Double check those endpoints. Look at the slope of your lines. There's a lot of ways just to noodle it out without having to even go through all of this work.